789 and 123, and they're all coming into the network. Now, what happens is all of the validating peers end up with the set transactions, but they get them in different orders. So we can see here, this one's got 456, 123, 789. This one's got 123, 456, 789. That's 456, 789, 123. And so we need consensus to decide which order we're going to process these transactions in, and we want the same order across all of the nodes in our network. So to do that, one of these nodes is a leader, and this is the VL one here. And he is nominated automatically by the network, and that role can pass around as the network runs. There is no operator control over who is the leader in the network. And the leader decides which order we're going to execute the transactions in, and publishes the order to the rest of the validator nodes. So you can see now they have all the same order, 1, 2, 3, 4, 5, 6, 7, 8, 9. Once they've decided on an order, they execute the transaction, so they call the smart contract, and then they update the world state stored in the peer. At that point, once the changes have been written to the peer, they're distributed throughout the network and available for all of the nodes to read.
Can I have a question like
sure.
how is the validating leader is nominated? Is random or you can predict it?
So the validating leader is picked completely randomly.
Right. And how can you be sure that the state in the validating leader is the correct state?
The correct state. So the world state will only be updated when all of the nodes agree and the block is added to the chain.
It seems to be that you assume the order 1, 2, 3, 4, 5, 6, 7, 8, 9 is the correct one, and you change the order of the unknown leader.
Yeah, so there's no particular order which the validating leader picks to execute these transactions. So it will pick an order. If you get a bunch of transactions in at the same time, it will pick an order, not necessarily, I know it's a nice example to have 1, 2, 3, 4, 5, 6, 7, 8, 9. It's just an order, and then it makes sure everyone else uses the same order.
Is the ordering essential?
Is the ordering essential? So everyone has to have the same order. So if I, for example, if we're trading a car, and you have the car, and you give it to me, and then I sell it to Liam, if my transaction to Liam happens first, but I don't have the car to sell, so we need a consistent order. If all the different nodes have different orders for these transactions, then the state is going to get messed up. Any other questions? So BBFT has some limitations. In a simple 4-node network that you might have been using over the weekend, that's sort of fine. But when you start coming to real-world networks with a significant number of people that want their own validating nodes, then it's not going to scale particularly well. I mean, here's a small car leasing demo. Apologies if your favorite car manufacturer isn't shown. We have 8 car manufacturers and 4 leasing companies buying cars from those manufacturers. There's also the green box in the middle, which is the DVLA, that's the regulator for this business network, and he needs insight into what is happening. He needs to know who owns which cars and when. In most business networks, everyone is known, right? No one is anonymous in a business network because there are regulators, they enforce regulations, which means we need to know who you are. For instance, things like KYC, know your customer, to know who I'm doing business with. Anti-money laundering, I need to know where the money is coming from before I take it. And since we know who is participating in the network, we can create logical rules about who should be validating transactions. Instead of 75% of the network agreeing that a transaction is valid, I don't need that. In my previous example, there's only 3 people that really need to agree that the transaction is valid. The seller of the vehicle, the buyer of the vehicle, and the regulator who enforces the regulations. No one else is interested. If I buy a car from Mazda, Toyota doesn't care, and I don't really want Toyota's permission to go and buy that car from Mazda. Now there might be other parties interested. We might have some banks, and they might have to participate and agree on the deal. But we really want to keep the set of people endorsing the transaction to a minimum. And PBFT doesn't currently allow that. There's also competitive reasons why we don't want everyone validating the transaction. In this example, Fiat give the two leasing companies different discount rates. And that's sort of confidential information. So if Lease Plus can start processing transactions between Top Lease and Fiat, and they can see that Top Lease are getting 10% discount, they're going to use that against Fiat in the next round of negotiations. Now, you can encrypt the data to try and prevent against that, but since you're executing code on Lease Plus's servers, their nodes, it's quite hard. So we really want to avoid processing transactions on competitors' nodes. And again, PBFT does not currently allow that. Questions? So the very smart people at Hyperledger have gone away and come up with next generation consensus. And validation is going to be split into two roles. There's going to be endorsers who sign the transaction to agree that it is valid. There's consenters who deal with putting the data into the blockchain. So instead of just validating peers and non-validating peers, we now have three different types of peers. We have generic peers who don't process transactions but carry the state of the blockchain. We have endorsing peers who sign the transactions and say, yes, that transaction meets the terms of the smart contract. And we have consenting peers who take the results of the transaction and add them to the blockchain. There's also going to be endorsement policies in V1, which is new coding support in the smart contract for saying who must endorse the transaction at the time it is being processed. And you can do that in code, so you can have policies such as all of the network must endorse this transaction, or 50% of this network and Robin must validate the transaction, or Robin and Ted or Marshall must endorse the transaction, or Lily but not Barney. So you can be really complex about who is endorsing your transactions. How does it work? So the client has to deal with a bit more work. It has to know who is endorsing the transactions. In this network we have 4 endorsers, E0, 1, 2, and 3. They have different sets of chain code because now not everyone is running the endorsement. They don't need all the smart contracts. So you can see E3 only has smart contracts A and D, whereas the rest of them have A and B. The first step is for the client application to send a proposal for a transaction to the first endorser. And the endorser will run the smart contract, check the results, and either say yes or no, or reject the transaction. And it will feed that back to the client. And at that point, the client has an endorsement for their transaction from E0. That doesn't meet the endorsement policy, so they need to send a proposal on to other endorsers and get more endorsements. Once they've got the full set of endorsements back from the 3 endorsing peers specified by the endorsement policy, they can send it into the pool of consenters who will take the transaction, the results of that transaction, and include it in the blockchain. Once the consenters have decided on an order for those transactions, they'll commit it and propagate the changes out. Questions? Okay. So the next big change coming in 1.0 is pluggable world state. Everyone familiar with get state and put state? Pretty basic. Has anyone tried querying data from the blockchain?
Yeah, I'm okay.
Yeah. Did you you don't like it? Or?
I'm okay.
You're okay. All right. So the data is stored in key value pairs. You get a string key and a byte array value, and that's persisted under the covers using something called RocksDB, which is an embedded database. It's very small. That's completely hidden from you as smart contract developers. You don't care about the underlying technology. But in reality, you actually do care, because the underlying technology there at the moment is not very powerful. If you try to do complex queries over the data you put into the blockchain, it's quite difficult. If you want to find all the cars, that's easy enough. If you want to find a car with a specified ID, that's easy enough. That's the key of the data. If you want to find all the blue cars, you can't do that at the moment. You have to scan all of the data in the blockchain, reading the ones that are blue. And so wouldn't it be nice if we had a powerful query language over the blockchain to find these things? So the Hyperledger guys are making the back-end data persistence layer pluggable, and they're going to introduce a CouchDB implementation. If you haven't heard of CouchDB, you might have heard of Cloudant, which is the cloud-based offering of it. CouchDB is a NoSQL database, and it deals with JSON documents, so you store JSON documents. So in the future, GetState and PutState will work with JSON documents, and they'll store them in CouchDB if you choose that option. And CouchDB comes with an extensive set of query capabilities you can use to access data in the blockchain. Questions?
Is it the same as Firebase?
Same as?
Firebase.
No, I think they're separate things. I don't know.
CouchDB is a NoSQL database.
Oh, similar style of database, yes. Yeah, a JSON document store.
So I'm saying it's the same as Firebase.
Is Firebase a NoSQL database? Yeah, it's NoSQL, it's not SQL based. Any other questions?
I think the question really, I think you meant that it's similar, so it could have been CouchDB by talking a different NoSQL.
It could have been. Yes, so it's pluggable. So Hyperledger will provide a CouchDB implementation. I assume the RocksDB implementation will stay, but you should be able to bring any database you want and use it with blockchain, with Hyperledger. That's the idea. Again, the smart contract APIs will sort of hide you from the underlying backend storage. So you won't know. You might need to know you're interacting with Couch if you need to use the Couch query language, for example. But hopefully they'll sort of hide that between, but I haven't seen any details of what that's going to look like. They're still working on this now. So that's the end of the new stuff in 1.0. So you've been using Docker. How many people know about Docker? It's quite a lot. Yeah, quite a few hands. So just in one slide, Docker is simply virtualization for applications rather than operating systems. You can run Hyperledger in Docker. Hyperledger provides a set of images across all the architectures Hyperledger is supported on. And here's the sales pitch. IBM also provides signed, fully supported Docker containers if you want those as well. You can use Docker Compose to create Hyperledger networks. And Compose basically takes a set of Docker containers and connects them together. This is a Docker Compose script. At the top is the membership service container, and it has some ports. And then VP0 is a validating peer. These are all the settings required to connect it up to the membership service container. Now, in reality, you wouldn't have a single node network. You'd have a more complex one. But samples of these files are available in the Hyperledger source. They use Docker Compose extensively throughout their own testing. So when you're running using Docker, this is what your network might look like. You'll have a set of Docker containers for the validating peers, and you'll have a Docker container for the membership services container. And they will all talk to each other over TCP. Hyperledger has two modes of running. One is development mode. When you want to run in development mode, you have to set this special flag called peer chaincode dev. And I don't think you've been doing this weekend because this you've been using the commands, I believe. So if you carry on with Hyperledger, you might see this around, so I thought I'd mention it. This allows you to start the chaincode yourself. So instead of the peer starting and running the chaincode for you, you can start the chaincode. Chaincode is just a simple application that connects to a peer. And this allows you to quickly tear down the chaincode and start it up again without having to go through the deploy step. So it can make your development process faster, but it does come with some limitations. In production mode, which is what you've been using, the peer starts the chaincode for you. So when you deploy your smart contract, it's built into a Docker container, and that's started by the peer. It's managed, it's also managed by the peer. And this provides a nice level of isolation for your deployed smart contract. It's in its own Docker container, it can't access the file system of the peer, fill it up, delete it, etc. Each peer ends up with its own copy of each smart contract. So if you have 4 validating peers in your network, you'll end up with 4 running instances of your smart contract on each system. So we have a 2-node network here, and they both have a copy of chaincode 1 and chaincode 2. They have their own running copy of the smart contract. So, has anyone got to building a client around their smart contract yet? No. Okay, so this is hopefully the more interesting stuff. So what does a blockchain application look like? There's the smart contract in the middle, which is the bit you've been looking at so far, but there's also the application that interacts with the smart contract. And the blockchain developer really has two jobs, and it might not be the same blockchain developer. He's going to develop an application that will call the smart contract, and he's going to develop the smart contract which enforces the business rules. The smart contract interacts with the world ledger state and creates transactions. The application doesn't do that, it does it by calling the smart contract. And you can see some events here, and I'll cover those shortly. Just to summarize, the application focuses on the user's business needs, so they don't care about the smart contract, they care about transferring cars, registering new cars, etc. The smart contract focuses on the business logic, so am I permitted to create a new car in the database? Am I permitted to read all of the cars from the blockchain? The ledger holds the state of the data on the blockchain, the current state, whereas the blockchain itself holds the sequence of all the transactions that were submitted to the blockchain. So you've been looking at developing smart contracts, and you've probably been doing this, you've been doing get state and put state to store data on the blockchain. And as I mentioned before, that's just a simple key value store. Has anyone seen the range query state method? So you can iterate over sequences of data in the map. So you can say, get me all the keys that start with B all the way to F, if you want. The other way of storing data in the world state is by using chain code tables. And these aren't very popular, but they are useful. They're not very powerful because you can only do very basic queries on them. You can select everything in the table, or you can select by key. This is an alternative to just storing arrays of data in key values form. And you get basic table calls, so you get create table, get rows for selecting data, and get row for selecting specific rows. This isn't very popular amongst the Hyperledger community, and I imagine that once CouchDB comes along and the pluggable data backends, we might see this stuff disappear, which you get for completeness. Who likes unit testing? Nobody. Damn. So recent changes in 0.6 allow you to write unit tests for your smart contract. And why do we want unit tests? Because we want a very quick turnaround to validate that our smart contract is doing what it should be doing. So I can now write unit tests in Go using the standard Go unit testing package that says, given world state X, when I submit this transaction, it makes these changes to the world state. I can save, if I have my editor set up correctly, I can save my Go smart contract, and within a couple of seconds all those tests will run and validate that my changes are correct. You can then take that and integrate it into other Go tools. You can use it with code coverage to check you're fully testing your smart contract. And you can integrate it into your continuous integration system. So if you use source control like Git, or whatever other source control there might be out there, you might want to automate builds of your smart contract. You can run some tests on your changes to the smart contract and then automatically deploy it. And you can do that using Travis, or Jenkins, or any other continuous integration tool. Has anyone seen chain code events? So it's possible for a smart contract to issue events. Why do we want events? Because we want to start triggering other processes based on an action from a smart contract. So if I create a car, then I might want to, on the blockchain, I might want to kick off a process to check that that car's okay. And when people are moving to blockchain, they're not necessarily setting up new applications from scratch. They're likely to want to integrate blockchain with their existing systems, their legacy systems. And they can do that with events. You can also do analytics over the data that comes out of the smart contract. So if I publish events every time a business event occurs in the smart contract, I might collect those using a logging tool such as Splunk, and then perform some analytics over the data. Client applications wishing to subscribe to these events can use APIs provided by the client SDK to get at the events and then publish them onto other systems. knew Go before this weekend? Who knew Go before this weekend? So Go is great, but it's not very popular. No, it's definitely popular. There are lots of people that like it, and it's a good programming language. But in the businesses that are looking to adopt blockchain, they don't have Go developers. You go to the big banks and ask them who is developing Go, they'll say zero. No, we have no Go developers. So the nice folks at DTCC, the Depository Trust and Clearing Company in the States, are a member of the Hyperledger community. They saw this and they went off and added Java chain code support. So you can now write your smart contracts in Java. And this opens it up to a much wider range of developers than it did before. If you've ever seen the PIOB Programming Language Index, which sort of rates how popular programming languages is, Java's right at the top. Go's moved up. The last time I did this slide, it was number 16 on the list, and it's moved up to number 13 in the space of a month or two. So it's going up. And you get similar API calls as you do in Go, so you get your get state and your put state methods. And you can just use all of the standard Java tooling that you come to know and love.
Very quick one.
Yep.
You said for 1.0, are you using 0.6?
Oh, yes, sorry. So Java is available in 0.6. It is fresh out for 0.6. So that covers the smart contracts. What about building applications that interact with the smart contracts? That's the bit at the top. This is the nice UI or mobile app that calls the smart contract. So if you're starting fresh, you're starting a new business and you want to build it around blockchain, you're probably just going to write some new code using some trendy UI, maybe a mobile app or a web app, and you're just going to write new code that calls the smart contract. For anyone with existing processes, they're going to have to integrate it into their existing systems, and that means doing something called integration. So they've got a nice picture of a factory, and it's going to have some existing systems around that factory, maybe using something like SAP. And what they need to do, they need to use integration to call the smart contract, so they need APIs for the smart contract in order to do that. Now are REST APIs, but those REST APIs are deprecated, and there's a reason for that. The REST APIs do not allow enough client-side smarts. The Hyperledger clients require a bit of smarts around certificate management. They require support for dealing with events. And the endorsement policies that I mentioned earlier, so the client needs to know that it needs to send off requests to a bunch of endorsers, get the responses back, sign that, and then send it off to the consenting note. So there are more and more smarts are having to go into the client, which means a REST API just does not do the job. And so they are building client SDKs. Now, the one thing the client SDK doesn't do at the moment is allow you to inspect the state of the blockchain. So if you want to get operational information like the number of blocks in the blockchain, then the REST API is still the only route to accomplish that. The first client SDK that's being released, and this is part of, I believe it came in 0.5, and it's fully out there in 0.6, is a Node.js client SDK. It's a Node.js module, HFC. It's available via NPM, so the standard Node.js packaging manager. And you can integrate it into any existing Node.js application. You might use it with Express to expose it as a REST API, but not just any REST API, you might build a business-centric REST API. So instead of the client SDK has a call called invoke for just calling a smart contract, but you might wrap that up into an API around cars. You might have a /update order status method instead. Node.js is the starting point. We picked it because it's cool and trendy. It's popular at the moment, but there are more languages coming. So there's going to be a Java SDK that's currently in the works, and also a Python SDK. And the client offers a set of capabilities for interacting with the blockchain. So membership, it allows you to register new users, allows you to log in and download the user certificates for use in sending transactions. It's going to offer some endorsement APIs for dealing with endorsers. It allows you to deploy smart contracts, so there's a deploy method. It allows you to invoke and query your smart contract, and it also deals with event subscription and handling. And this is what a Node.js application looks like using the HFC module. Can't really point, but at the top we set up the connection details for Hyperledger, then we use the enroll call to log in. Then we can start submitting transactions. So if you can read that, it says add to balance. We're going to call the add to balance smart contract method. We're going to pass in some arguments. The chain code ID, which you've probably seen this weekend. And we're going to get some events back from this transaction context object once that transaction has completed. So that's all I had to cover. Any questions?
Why not add Node.js to the code as well?
To smart contracts. That's a very good question. So I think that will hopefully come at some point. Currently we have a very weird story around programming languages. We have Go and Java on the smart contract side, and we have Node.js on the client side. And we definitely need one programming language in both places. I think Node.js would be a pretty popular choice if we did it. But we might also see other programming languages in the future. I can imagine that we'll see C# at some point to get some of the Microsoft people on board. And we might also start to see more legacy programming languages, maybe something like COBOL, although I wouldn't want to go near it. But we also might see another type of languages, which is more sort of custom languages. Anyone that's come across the term smart contracts probably wouldn't call it a contract. It's probably a contract programming language. You show it to a lawyer, they'd probably be quite terrified. So we might see a more legal approach to writing smart contracts in the future. We'll just have to see how it goes. Questions? Okay, well I won't keep you from your lunch. Thank you. Oh, sorry.
The question is about the actual slides.
Yep.
Can you make those available?
Yeah, sure. I don't know how, but I'll figure it out. There's a Slack.
Send this to me, please, and I'll publish this in the Slack.
Alright, cool, thanks. On the subject of Slack, there's a bunch of links at the end of the slides. And Hyperledger have a Slack channel, and it's really active, so you want to ask some Hyperledger questions and get some help. They're really quite active on there.
I have one more question. So
Sure.
if you actually go to the Hyperledger GitHub, it's a little confusing, especially for somebody new, because you've got Fabric and then you've got Sawtooth and some Japanese company called Iroha, and they all trying to do the same thing and you're never sure which one to use.
Yeah, so everything you've done this weekend is using Fabric. IBM is looking at Fabric. Sawtooth Lake is contributed by Intel. It's a similar blockchain, but it's incompatible. Iroha, I haven't really looked into, it's something new. And you may have heard of Corda, which is coming from R3, and that's going to come along, I believe, at the end of the month. And so that'll be another project. What we'd like to see is just one standard, but that's not the case yet. I don't know what will happen over time. It's up to the community to decide how these blockchain implementations go on. I would guess all the best bits of all of them will be combined into a single offering to remove the confusion in the future. But it's still early days. This is still it's not research code, but it's close to prototypes and playing around and seeing what's possible with the technology.
Just a basic admin question. The Hyperledger Slack has got the Slack details. Or how would someone get invited onto that Hyperledger Slack?
The Hyperledger Slack should be public.
No, it is. Oh,
Yeah, it
You-
is
yeah.
public. You can just search for it on Slack. Hyperledger projects public. And then there's lots of channels underneath it for all the components.
yeah. Because normally with Slack you have to be invited by someone.
Only for private channels.
No, that's the case for channels.
No, I'm sure the Slack, whatever the Slack thing is public. You should be able to sign up with any email address.
Oh, okay.
It's completely open source. It's an open community, so you should be able to join. For those of you that want to go deep into the code and maybe their issue tracking, they don't use GitHub, and they use GitHub as a archive of the source. They use something called Gerrit, which is a project tracking system, and that's a bit harder to get into, and you need a Linux Foundation ID to access it. It's free, but it's just not obvious when you want to try and get into it, and nor is Gerrit really. It's pretty horrible. Anyway, any other questions? Oh, okay, I'll leave you to your lunch. Thank you.